Hello, my name is Jawad Saadi and I'm the Managing Director of Hexatronic Security and Surveillance. And I welcome you to this InOne online showroom. In this showroom, we're gonna have a little bit of a hands-on presentation about the InOne solution. This is a recorded video. It's part of a series of videos. We're trying as much as possible to keep the videos short. I'm going to refer to some few things. You will find more detailed videos in the video library in the link below. Let's get into the InOne. The InOne is a hybrid fiber and power solution. To put the things in context, let's go first into a technology that you know very well about. Let me switch to this chart and talk about PoE. PoE is a standard that we all know about. PoE have actually, all type of devices are using PoE. It solves a very big problem that you don't need two cables, one for power and one for the Ethernet. The issue with PoE, despite that we have higher bandwidth that we can support with the Ethernet protocol, and with the PoE++, we can reach 50 watts and 70 watts. But there is a limitation of the distance. The standard called for 100 meters distance. There has been some companies, I'm not so sure about the quality of these products, but there are companies that have made extended PoE for a few hundred meters. But what about devices that are beyond that? What about devices that are in a kilometer distances in the outdoor? So, and this is what the InOne is about. So let's switch to the main camera again and talk about the InOne. The core of the InOne solution is this hybrid cable. This is a cable that has both copper and fiber cables, and it's made to connect devices up to long distances of kilometers. So let's get into the details. All right. So on my right side here, this is an outdoor or a street cabinet for the InOne. This is usually located in the central part of the network. Whether you have it outdoor or inside your data center, the components inside are the same. So let's open this cabinet. And here what we have our power supply. It converts AC to DC. And the DC here is, we have an output of 110 volts DC. And then we also have from our core network, we have the fiber feed coming into the fiber ODF, and we have that fiber connected and the power to what we call here is the hybrid ODF, which is part of the InOne solution. What the hybrid ODF does, and this is a hybrid ODF, it combines both the DC power and the fiber into the InOne cable that we can then have the InOne cable connected to our remote sites and remote locations. If you see in this example, we have the hybrid cable blown inside a microduct, and we're going to talk about those a little bit later, until we reach the device. And let's move to the other side of the room. And this is the InOne cabinet where this feeder cable is coming in, and we have two cables coming out feeding the other cabinets. In this example, we have here a sun shield, and this is for extremely hot climates. So let me remove the sun shield and open up the cabinet. And here you see that we have the incoming cable coming into the cabinet. Let me bring you a bit closer here. So here is the feeder cable, and here we split the fiber and the power. So the power cable is doing two things. It is directly feeding the outgoing cable, and it is feeding the power supply that is behind this connection board. Behind this connection board, and actually behind this plate, there is a solid state voltage regulator that has no fans, no moving part, that outputs the 48 volts regulated. Now the other side is the fiber cable. So we bring in the fiber into this cassette. We take the 2 fibers for the switch that is here, and the rest of the fibers are then continuing moving other parts of the network. Up here we have the switch, and we work with different switches. This example is a ComNet industrial switch with 4 ports PoE. And here we connect our PoE devices, whether they are cameras, base stations, or any kind of a PoE device. This whole cabinet is made out of cast aluminum, and the power supply behind this plate is connected directly to the cabinet, so it acts as a heat sink. So the cabinet is an important part of the total solution. So let's now talk about the different components. Let's talk about the cable in a little bit more details. Here I have different examples. We have 2 sizes of the cable, one with 0.75 millimeter per core, and the other one is 1.5 millimeter per core. If you notice here that we have 4 copper cables, just to keep the cable round, and we have the fiber in the middle. We have the fiber, we have up to 24 fibers, but since we are the manufacturers of these cables, on larger orders we can actually make cables to specs. We have another variant of this cable. This cable is fire rated for the applications that require that. The second part of the component is actually the ducts. And here you have 2 options. If you have an existing ducts, you can definitely take these cables into your existing ducts if you have the network already. But also we have the Hexatronic microducts. And these microducts, you can actually blow the cables inside them into long distances. And please, it's lots of details about that. So watch the video that talks about blowing fiber and our microducts. We have a wide variety of ducts. We have single, we have direct buried, we have inside duct, we have aerial duct for suspended installations, and we have armored ducts for applications that need that, and for under water. Now, the network topology, the beauty of the InOne, that it does not require a specific network topology. We can install the InOne in a bus or a star topology. We can fan out, so to have a combination of the both. And we can actually close the loops in a ring topology for redundancy. So if you have a cable cut, both the power and the fiber is fed on the other side of the ring, and that's achieve redundancy when it is needed. The most common question is that we get is how far can you connect the devices? What are the distance limits for the InOne? And this is answered by that we have a power budget. In this example, we have a 400 watt power supply. You can have a 1000 watt power supply, and then you start with that. And depending on the distances you have and the loads of your devices, there will be losses. And based on that, based on the network topology, the distances, the loads, the type of cable, which is the diameter of the copper, then we can get the answers of how far or how many devices can we put on each node of the InOne. But the good thing that we have a design tool that you just enter the load of your devices and the distances, and then it will make all the calculations for you considering all the different parameters. So we help you with the design tool, and we do help customers in making the design because we have lots of experience from many different projects, so we're able to optimize the design as much as possible. So I haven't answered the question, what's the maximum distance? If we take the 1000 watt power supply and we have a single load point to point, for example, a PTZ camera with 30 watts, then you can have a distance of up to 7-8 kilometers. But in the end, this is one example. Depending on the number of devices, the network topology, we can do the design and help you with that. So this is a brief presentation. Let's try to summarize and talk about the benefits. We have big claims about the savings. We have worked with many different projects, and we're yet to see a project that we haven't achieved savings. The savings can go up or down depending on many factors. The civil work in the total turnkey project is usually a very big part, and this is where the InOne makes the maximum saving. If we show, for example, a traditional, if you have to put AC power, then you're probably going to be using ducts like this with big power cables. If you're not going to put the power cables in duct, then you have cables as thick as this. This is an actual sample from a project that we worked with a customer, that they started with this, and then they're converting to the InOne. Then you need a separate civil network, and usually use ducts like this with traditional fiber cables. And then you have two different civil works. But with the InOne, all you need is, this is a direct burial duct, and this is the cable inside it. So you replace actually the two civil networks with one. And this is, I mean, the saving in that is very obvious, actually. Each country have different specifications regarding the depth, but when you have this small duct and this small cable, and because you can run this and you can blow the cable on longer distances, you have less needs for handholds. It is less excavation, less backfilling, faster deployment, which takes us to the second point, the speed. The implementation of the InOne cable, because it's a smaller cable, the logistics are much easier and faster. When you're using the microducts and you're blowing the cable, then you can have a much faster deployment. So the first one is the saving, especially in the civil work. The second one is the speed of deployment, and this has a direct consequence also that provides savings. Then it is security. And security is, in many cases, that what we notice with our customer projects, that it is, I mean, sometimes customers do not have power. And the InOne is perfect because it supplies the fiber and the power in one cable and one civil network. But there are other cases that there is power, but it is not their power. So you have a critical application, like you have a monitoring system, or you have thermal sensors for industrial pipes, or you have CCTV surveillance cameras. So these are critical applications. And there is power, but it is not your power. It's somebody else's power. It's probably from the lighting system or somebody else's power that you cannot rely on it. If you deploy the InOne solution, and deploying the InOne solution is exactly, if you're going to put in fiber cables, you might as well put in the fiber and power in one implementation, then you have your own power. And that provides you with the security that you are supplying your own fiber with your own power as well. The next point is redundancy, and redundancy is achieved in two different ways. The first one, that at the power supply, as we showed in this cabinet, you can have a UPS. So if there is a power failure at the mains, the UPS continues to feed your network. And the second way you can achieve redundancy from cable cuts is to close the rings of the cable. So if there is a cable cut, you feed the network from the other side. A combination of both UPS and rings will give you the maximum level of redundancy. And last but not least is the flexibility. Because we do not have a specific network topology, we can follow the best route that you have. We can follow the most economical route, whether your devices then are connected in a bus or a star topology. It doesn't matter from the InOne perspective. So that achieves a lot of saving, lots of flexibility, and because of the flexibility of the InOne solution, you can always add devices to the network. So if you have a point in the middle, you can actually cut the cable and put in a new InOne cabinets and put more devices, or you can extend the bus. And depending on how much expandability you are expecting in the future, that's a design input to keep a little bit of space in the power budgets for future expansions. So this is the InOne solution. Please watch the other presentation that talks about in a little bit in more details about the InOne. Also, we have detailed videos about the design, the saving, and the blowing the cables, the blowing technique. But also, you have seen now the setup of this online showroom. You can actually, from our website, which is hexatronic.com/InOne, that is also linked below, you can book an appointment so we can have one-to-one video session, and then we can go into the details and the questions that is more specific to your needs and your project. I thank you again for your attention and for watching this video, and hope to see you in this online showroom. Thank you so much.